In this episode, we are going to code a graphical user interface from scratch in C. We are going to design an interface inspired by the Macintosh Classic macOS version. We are going to write our code so we go from this to this and to this. Let's get started. Sup guys, welcome to today's show. So, ladies and gentlemen, today we are going to code a graphical user interface. And we're going to do it from absolutely scratch. The same level of code as Windows 11 is coded on, the graphical user interface of that. Same as the X Windows system for Linux, and same as Mac OS X. So we're going to code a real graphical user interface by writing directly to the hardware, such as the graphics card and the BIOS and the mouse controller and stuff like that. And we're going to do everything in a virtualized environment using a program called DOSBox, and that is because that's the only way we can write to, or it's the easiest way that we can write directly to hardware. Alright, so if you're on a Windows machine, you're going to install Cygwin. That is a compiler that makes it possible to do these things. That's only possible in Linux otherwise. You're also going to need DOSBox and NASM. If you're on a Mac, you're gonna need GCC, Make, DOSBox, NASM. And the easiest way to install this on a Mac, that is to install a program called Homebrew. And then you can just go into a terminal and write brew install GCC, for instance. And if you're on a Linux, you can just follow along as I do, because I'm gonna compile the code on Linux and then copy it to my Windows machine and run it, because I think that is the simplest, or at least I like that way of working. So, but you run the same commands locally on your machine if you don't have a virtualized Linux environment. So the first thing, I'm going to go to my TMP directory and create a GUI directory. Inside of there, I'm going to create an include directory, and inside of there, ASM. So we're going to code this project in C. At least 95% or more is going to be C. But some stuff you can only do in assembly, like writing to the hardware. But in that case, I will write a very, very small function, like 5-6 lines, and then I will put all the logic in the C file. So you don't need to know any assembly to follow along here. You only need to know the basics of C, because we're only going to use pretty simple constructs of that language. Alright, so I will set this to my home directory. And since I'm gonna code remotely, I'm gonna use the Sociopath STP client, which makes it possible for me to edit files remotely. This is freely available online if you want to use it to connect to your machine. Alright, so let's go into TMP and GUI and open in editor. That way I can use VS Code on my Windows machine to create all the code. And as you can see, we have the directory structure with the include and everything. Alright, so we need to set up a couple of things. Since we are going to write to hardware, everything is done in 16-bit code. and that will not affect the actual C code very much, but we need to do some setup. So let's do that. I will start by just creating some C files. I will have a main.c. And inside of here, I'm going to have a void main. And usually when you code C, you will have an int main. But this will be a little bit different, as I said. Not much, though. I do also want to have an include file. Let's call it GUI.h. And I will just put in a return statement here for now. Alright, so I'm going to name all my C files .c, and I'm going to name my assembly file x and then the name. So we can easily differentiate them even when we have compiled. So for instance, I'm going to have an xgfx.asm where we're going to put basically all the assembly code. And then we're going to call this from the C code. This is going to bit 16. And we need to include, and let's call this xgfx.h. Something like that. And inside of the include directory and asm, I'm going to create this file. So xgfx.h, xgfx.h, and this is bit 16. And I'm going to change this C++ down here to an asm because .h is usually for C files, but I use it for both. Alright, let's save this. And also, what did I call it? GUI.h. So that will put inside the include directory, not the asm. So let's see how we do that. Well, we can probably do something like this. If you do GUI.h, it's in the right place. Okay. So GUI.h, and I'm going to have a pragma, so this is only run once. Okay. We're also going to need a make file to make this a little bit easier to compile. And I'm going to start by defining some flags that we're going to use when we compile. So we need to remove the stack protector. That is a protection feature which usually is very good to have, but not when we need this low-level access. I'm going to also set O0 to remove all the optimizations. I want to have a W all, so we have some error messages and warnings. And we're going to use the C standard of GNU 23. And this is only available if you have the latest GCC, like version 14 or something. If you have a slightly older, like version 12, you can replace this 3 right here with an X. And that's the same. But if you have an older version, you just delete this. All right? And then we are going to need some special things. We want to compile this as 16-bit code. Um, and we're gonna compile it for I386. I don't remember if we're gonna have double here, I think so. It's gonna be freestanding. Okay, ran out of room. If we run out of room, we can do this. Let's see, flags. This is how we define it. And then we do flags plus equals F free standing. I'm not sure about the hyphens here. And that's probably it. There might be something more later on. We also need to have some LD flags when we link. So we're gonna have a nMagic, and I'm not sure really what that does actually, but it's supposed to be used in this occasion. And we need to have a script file. Let's call it GUI.ld. So that's that, and let's create a couple of rules. I want to have a clean where I delete all the .o as well as all the .com. And we're going to compile. Let's create something called objects, which contains our C files. So for now we only have a main.c, and this is going to be a main.o. And then we have X objects for the assembly files. So we have an X gfx.o. And then we create rules for these. So main.o comes from main.c. And we're going to run our compiler with the flags. We add -c and we take the source file. And the assembly file we do similarly. So we have gfx.o from xgfx.asm. We run nasm with, let's see, we run it with -f. We're going to create elf at this point. So we're going to create object files in the elf format, and then we're going to link everything to a raw binary. So what we do is we take the source file and we produce the target file. That's what this means. When we have those two, we can create our final binary, which I'm going to call GUI.com. And in order to compile this, we need the objects. And it's important that you take the objects before the X objects, because we need our main to run first. Okay. So what we do is we run our compiler. No, we don't. We run our linker with our LD flags. We take all our source files and we produce the target file. So we'll also set a phony, which is clean because that doesn't produce anything. And then all we're going to do is compile our GUI.com. Alright, so one more thing, by the way, we need to take care of the include files. So we do that differently for C and for assembly. For C, we just do -i, and we tell the include directory. For NASM, we create an environment variable, which is called NASM env, and we set this equal to -i include asm, like this. I think you need the slash at the end, or you should not have the slash at the end. I can't remember which. We also need to export this NASM env, like so. Okay, just one more step. We need to create this script file. So let's create GUI.ld, and this is just a file that tells the linker what kind of binary we're going to produce and such things. So we're going to have a, let's see, output. Output something. Let me just check the manual real quick. So ld script file. This is going to be object file format, output format, of course. So our output format is going to be a raw binary. And then we need some sections. So first we need a text section. And we're going to take the text sections from all files. That's what this means. And we're going to put it right here. We also need an entry point. So this depends a little bit on your environment. When we are dealing with DOSBox and MS-DOS applications in general, the entry point is, the origin is at this address. So that's where we start our memory for this application. And we're also going to have a data section. I can never really remember. Maybe we should have this here, but here. And the data section should contain the data sections from all files, but also the read-only data, as well as the BSS for static data. Let's also tell our editor that this is an LD, let's see, linker map file. Let me just check if I forgot anything. Entry point we don't need to set. Let's see that we have the correct format. So sections, this dot text, and then this. And we don't need to specify memory location. Looks pretty right. I also want to add one more thing, and that is a heap. And I want to align this to 2 bytes. All right. I think we have most of what we need. We also need to add one thing at the top of your main C file, because it doesn't know what function to run at the beginning, since we are doing everything so low level. So we need to add this. So we want it to, first of all, we want it to be code 16 GCC, and that just means that this is a 16-bit code. GCC. Also, we want to call our main, and afterwards we want to call exit. And this needs to be absolutely on top, no include files or anything prior to that. Alright, let's see what we got and if it's possible to compile this. Did you mean F freestanding? Yes, I did. So let's remove this hyphen here. Didn't like March, so let's try with only one dash. Isn't it March? It's something Ma, anyway. So let's see. Never mind. I'm not sure we even need that actually. So let's remove that for now. Raw binary. Maybe it's supposed to be in caps. And I'm doing all of this from memory, so that's why there are a couple of errors. Let's double check this output format. So object file formats. And we need to objdump -I. Maybe it's just binary. It's called a raw binary, but maybe we just do binary here. Undefined reference to exit, that's true. Let's do this exit call. So I think it's something like int 21 or something. So dos int 21. Program terminate. So AH is 0. And we just run this, okay? So that's pretty simple. All we need is going to this ASM file. We define a label called exit, and every function starts with pushing the BP and moving into the BP, the SP. And then we zero out AX in this case, because we want the AH to be 0, and then we run int 21. And if we are still alive at this point, we can produce an endless loop. So we'll have something like halt, which is just let's see, clear the interrupts, we halt, and if that also fails, we jump to halt. And just to manage my OCD, I want to move into SP the BP, and we pop the BP and return. That's just how we end a function. And we need to export this, which we do with global exit. Alright, so now we should be able to exit our program. That's true. It should be AXAX. Alright, so now we have a GUI.com, 100 bytes at this point, and if we objdump this, I have an alias for 86. You can see how it looks. So alias objdump. So no, I don't have it here. Alright, let's just do objdump GUI.com as this. -d. Right. We need to set what kind of target it is. So let's add B binary. And architecture Intel 8088, 8086. And this should be a big M. So, -M. There we go. Alright, so this is how our program looks. And as we can see, at the top we have our calls to, this is main, and this is our exit. And this needs to be on top. So, looks right. Alright, so now we need to set up our local environment, and that might be the same environment for you. So after you have installed this DOS box, you can just Google it. Let's create a directory somewhere in the root of your program. I have experimented a little bit before. I can delete this. So let's create a file, folder which is called dos, and let's put it directly inside of your C colon drive, because that will make stuff easier. And inside of here, this is just this step is only necessary if you do like me to compile stuff in a remote machine. In that case, it simplifies stuff if we have something like make.bat, which is a very simple script file. Let's edit this. All we're gonna have is echo off, and we're gonna copy the file from the server. So we'll do SCP and username at and the IP address of the server, and this is inside of tmp GUI.com, and we want it to be put, let's put the whole path inside of C colon / dos, right? That way we can just go to run and do /dos /make.bat, enter our password, and it will automatically update the file. Nice, huh? So now we start DOSBox, and this is going to be a little bit tiny on the screen. I'm not sure if it's possible to do full screen. We can try. I hope this looks right. So the first thing we need to do every time we start this thing is to mount our directory. So we do mount C, and it's C colon dos. And now we can just type C colon, and we're inside of that directory. And we can run our GUI by typing GUI. And nothing crashed, as you can see. Nothing happened, but it's an empty file. So that's why. But it worked. All right. So now the environment is set up, and it's all we need to do is code everything. So we'll be right back after this. Sup guys, we're gonna design our window system, and we're gonna create the images that the graphical user interface will use to load the window images from. So the first thing we need to do is define a palette with colors, or grayscales in this case. And you can do this a number of different ways. And I think the easiest way is to create a simple HTML document. So that is what I'll do. So you can work locally. I will connect to my server. And I will create a HTML file. I'll call it palette HTML, and you can use any text editor. I usually code in VS Code, but since this will be some little file, I will just do it like this. So we'll have a head, and we'll have some, maybe I should indent a little bit, and this will be the style portion. It's been a while since I did this, but I think this is the correct syntax. So I will reset everything first. No border. And I don't want any margin. And I don't want any let's see, we have margin and we have padding. So 0 there as well. Alright, so now I will define a container. So let's say that is our main. And I will do this as simple as possible. I will set display to, let's see, flex. And I will set the flex direction to row, because I want this to grow to the right and not downwards. I will set a gap to 1 rem, and 1 rem is the same as the font size of the HTML container, so let's set this as well. Let's see, is it font size perhaps? It was a while since I did this. I think this is the right thing. Alright, now we're gonna have our actual color things, and let's make this divs. So let's say we have a height of, I don't know, 100 pixels and a width of 100 pixels. I want to have a border of 1 pixel solid black. Alright, so let's see, we have this border, and I think that's pretty much enough. So let's close this. No, not script. This was style. And let's close the heads. So now let's do the body. That will be very simple. So the only thing we're going to have is this main container. Then we're going to have a couple of divs. And I'm going to say div class is equal to C. And then I close the div. And I remove this and I paste in, let's see, 16 copies of this. And I'll give each of them a unique class name like this. Which is probably a little bit easier in your text editor, but we'll make do. And actually I'm gonna remove one of these. Let's see, C1 I'm not gonna use. Instead I'm gonna have an extra CFF, because I want to have a complete bright white one, and I will only have 16 colors to work with. So let's close the main, let's close the body, and let's close the HTML. Alright, so before we go to the actual colors, let's see what we've got this far. So this will be on my website, drbirch.com/palette. Yeah, I think this is going to work, but maybe we should have a little bit of padding after all. So let's go to the main and let's set a margin of 1 rem, and maybe we can change the, let's see, the height to 60 or something, and let's do 2 pixel here. Oh, that changed quite a bit. Oh, 600, I meant 60. Okay, this looks pretty nice, right? So let's fill these with colors. And how to do this is in an easy enough kind of way. I was thinking something like this. So we'll have a class of C something, which is just going to contain a background of some color. And we need 16 of those. So we'll do like we did before. And add all those numbers. And we'll remove C1 and add a CFFF, just 3 Fs. Okay, so what colors are we going to use? Well, if you have done any web development in the past, you know that all colors are defined like this. So we have 6 hexadecimal digits. The first 2 is red, then green, and then blue. And all the gray colors have a 0 in between. So, for example, co is a light gray, and 20 is a dark color. So we'll just go through all the combinations. So first we will have a completely black, which is 0, 0, 0. And since all digits are the same, we don't have to specify all 6 of them, just 3. And then we would have 10, 10, 10, but we skipped that, so this is 20, 20, 20. And then we just move on from there. And don't forget to put the semicolon at the end. And you might ask yourself, is this really the easiest way to do this? Isn't it just easier to go into our graphical user designer program like Photoshop or whatever and do this manually there? Well, maybe, but I'm not so sure that will actually go faster. And this HTML file we can easily reuse with a different palette later on. And this is going to be F0, F0, F0. I forgot my semicolon here. And then we're gonna have a bright white at the end. Alright, let's see how this looks. Huh, look at that. Pretty beautiful, if you ask me. Alrighty then. So now we'll just take, maybe I should decrease the gap just a hair. So let's go to this and say that the gap is 0.5 rem. Okay, that's good. So now we just take a screenshot of this thing. And I'm not sure if I can take a screenshot while recording. Let's try. Seems like maybe I can. So this will be something like this. And yeah. Okay. So now that we have our palette, I will name this palette.png. Move it here. All right, so the next step will be to design our actual window. And I'm gonna design it to be similar to the Macintosh Classic interface. So I will go to the internet and have a reference image. That makes it a little bit easier to design. So I will just search for Macintosh Classic interface. And we go to images. And this is probably what I'm looking for, right? So let's just copy this thing. And we're not going to use this as the end result, so we don't have to worry about any copyright or something like that. So let's call this, I don't know, template. And what program are we going to use when we code when we design this thing? You can actually use Paint or whatever program, because this is not advanced stuff. However, I am going to use Illustrator in this particular case, just because I think it's a little bit easier to work with that. And if you too are going to use Illustrator, let's see, let's just pick one for now. What we want to do is we want to place our template in the background so we can easily use that. And there is some function for that. If we search for place, right, so we go to the file menu and we select place, and then we go to our directory and find our template, and we should select template here, because then it will be in the background like this and it will not influence anything else. Let's see if we can scale this thing. Maybe we can't. Alright, doesn't matter. We can just zoom in a little bit on this. Alright, so now we want to create something similar to this window right here. And we don't want to just copy it exactly, but we'll make it pretty similar. So let's start with, by the way, we need to get our palette as well. So the easiest way, I think, is to just go to the desktop and open this palette in well, any painting tool. I'll use Photoshop in this case. And then we select all, we copy, and we close. And now we can just paste this thing here. Let's scale it down a little bit. We can put it here, maybe a little bit more. Alright, so if we now zoom in on this thing, like so, now we have our palette easily available. And we can even lock this thing so we don't click on it and move it or something when we don't want to. Alright, that's all fine and well. So let's start by drawing this window. So let's start with a frame. And the frame is one of the darker colors, but let's start out with just some black. And what we need to do is we want to open up the color window, this one. No, not that. And I can close this thing. Right. And let's find this color picker. There we are. So let's pick black for now and just draw a window like this. And we need to remove the fill. Like so. We do, however, want a stroke. So let's say 1. Alright, so now we have the basic window right here. Okay, so what's the next thing? We're gonna have some window text like this system folder, like right here. But that text we want to add dynamically. So I wonder if we should have some placeholder there just for the design. Maybe. Let's do a placeholder for now. So let's say this is the system folder. And let's not worry too much about the fonts right now. But I do, however, want some well, something a little bit different. Maybe we can use cache a code. And a little smaller. Something like 10, I guess. And we'll move this so we get it in the middle. There. Maybe we can move this whole thing to make it a little bit more center. It seems like it's shifted to the right, isn't it? I think so. Well, it doesn't really matter. This is only a placeholder anyway. All right, so let's do this gray part right here. So let's just draw this out. We need to save a little bit of room on the top and a little tiny bit on that part right there. So the room is a little bit more on the right. I don't like that. Okay, that's better, I guess. And maybe we don't need that much space up there. Okay, something like this. And let's make a copy. Move this out a bit. And then we shrink this to the left. And we put this right here. Shrink this like so. And maybe we should move this up a bit. No, not like that. This looks pretty much the same, right? We won't worry about the colors for now. We'll do them pretty much last. Okay, so let's do this close button here. That will just be a box. Something like this. And let's give this a white fill. And we want to make sure it's the exact right one. So let's do this. And we also want a stroke on this thing, but not as big. Maybe 0.5 if that's possible. Seems like. Okay, and well, let's not worry about colors for now. And let's move this into position. We should leave a little bit of space to the left. Okay, starting to look pretty nice, I think. Okay, so what's the next thing? We have a box around this status field right here. And we have, well, let's start there. And I think the easiest way will be to copy this thing Sorry about the sound, some neighbor is drilling or something. And this should be right here. So let's give this a temporary different color just so we can spot the difference. And this one should go all the way here. Right. And maybe we can make one more copy of this and move this down a little bit. And then we'll make this one white. And we move it back. But we do want the stroke. So let's put 0.5. Okay, almost right. Maybe move this down a little bit. No, not that one. And in this case, it's almost impossible to click on the one in the background. So one trick is to click on this foreground thing, go to Object, Lock, Selection, and now we can click on this bottom thing and move it down. So something like that, but we do want the stroke on this one because the size will be different otherwise. Okay, something like that. Starting to make sense, and this too should have the stroke. Okay, now it's nice and symmetrical. I don't like this though, so let's unlock again. This we need to relock. This white here, if we zoom in a little bit, I don't want this gray space there. Okay, that's better. Okay, we are closing in, ladies and gentlemen. Maybe we should put some placeholder text there as well, just for now. It's important to remove that when we are going to use this though. So let's say we have 5 items. This needs to be smaller. And we need to have this other one as well. So 211K in folder. This should be right in the middle. Maybe we can make it a little bit smaller. This too. Okay, that's nice. And the last text as well. One, 73K available. And this should be in line with the other one, but to the right. Okay. It's starting to look pretty nice, I think. The icons in the middle we are not going to do because this is going to be a window which should be used for all different kinds of things, not just this. By the way, this should go all the way, right? And same with this white part. Let's unlock. Let's go to this white thing. And let's move it out. Move it out. Alright, looks pretty good. Let's lock this. So what is left? The scroll bars. Those we do need. Alright, so let's make another box. We can model it after this one. Move it all the way to the bottom. And let's do one more. Only this we will change. Let's see. No, we want to make sure it's the same size. So let's rotate this instead. And this is why it's good to use Illustrator, because that would be difficult in Paint, for instance. And let's move this all the way like this, so it intersects, and let's remove the fill, so we get that thing on the corner as well. And we need that little icon, and that's just 2 boxes, so let's do those. We can model after, let's see, we can use this one as the background one. And then we can use this one as the foreground one, because this is not transparent. Something like this, only this needs to be smaller. Yeah, looks right. And we can even group this thing and move it into position. Maybe we can scale this a little bit, just so it does not intersect. Okay, pretty nice. And then we need the arrows. How to make those arrows? Well, basically it's just a triangle and a square. So let's do that. So let's start with, maybe we can use the pen tool actually. So let's just do something. We can do it quite big to begin with and then shrink it. So let's do something like, I don't know, this. We want this to be a edge. Maybe we can just do it like this. And this and this. So that's one part. And then we want the square as well. So let's do something like this. And if you hold down Shift, it will make these 90-degree angles, which is good in this case. Okay, so now we have the basic building blocks of this arrow, but we have extra bits here as well. So if we select this whole thing and we go to, where is it? My favorite tool in this program, Shape Builder tool. So the good thing with this Shape Builder is if you hold down Shift so it becomes a minus like this, we can just do this and remove stuff we don't need. And we can do it here as well. No, we don't want to remove all of that. Maybe we can just do this. Let's see. No. Let me just think. Maybe we can just select this one. And we go to the Shape Builder. And we do the same thing again. Okay, sometimes it's a little bit tricky to do these things. Maybe we can cheat a little bit. We select this right here and we give it a fill. So let's go like this. Okay, we do need to have a stroke as well though. 0.5. Let's select the whole thing, and now we go to the Shape Builder tool again, and we click there. No, what we do is we select a color and then we click here. What if we select this thing? No. The problem is we did this freehand. I think that's the problem. Maybe we could just do... You can take the white arrow. Then we can select smaller parts and we delete. No, we don't want to delete all of this. We just want this thing here. Okay. Sometimes it's a little bit tricky, but we figured it out. Alright, this looks pretty good, but we do want to remove this line here as well. So let's select this point and this point. Delete. No, that deleted too much. this. Okay. What if we were to select this whole thing? We go to the shape builder and we try to remove there. No, that's too much. Ah, there we go. Okay, that's a nice arrow, isn't it? I think it is. Alright, so let's make a copy of this. Let's shrink it down. Something like that, I guess. What did I just do? Okay, so let's shrink it a little bit on this axis, and let's also just make it a tiny bit smaller, and let's make a box around it, which should be this size. Let's move this down till we have a square like this. And let's put this thing in the middle. And let's give this thing a white fill. Preferably without removing the stroke. Like this. And now we can move this. So this should be on top. So we can go to Arrange and bring it to front. And if we take this back box and we give it a fill, and we put the stroke back, 0.5. Okay, so now we can put this anywhere and it will not be transparent. So let's group this to one thing and put it in place, which was a little bit more difficult than I thought. How does it look on this thing? It's no gap on the side. Let's make a copy of this, by the way. And let's move this into position. If we go a little bit closer, I think we can arrange it a bit better. We want to move this freehand. I wonder why we can't do that. let's shrink it a little bit then. I don't really like that. Okay, we don't have that perfect granularity here, but let's do it like this. Maybe it's even better. Alright, so let's make another copy of this with a new size and remove this. And let's rotate this thing. This should be right here. It is starting to get a little bit annoying. Okay, that's the best we can do for now. And then we do need a couple more. Rotate this like so. And one more. Okay, starting to look pretty nice, I think. I wonder about this line right here, though. I think we should move this down a little bit. Because there should be white space there. What if we were to remove the stroke? Look at that. But this became a problem instead. And now we are off a little bit here instead. Maybe we can move this outer frame closer to the camera. So if we take this and we arrange it front, there we go. Isn't this beautiful, ladies and gentlemen? I think it's beautiful. Alright, so let's pick a color for this thing. And we should have a rather dark gray stroke. So let's see what's the easiest way. I think we can, well, let's do a color picker and select one of the darker ones. Then we go into this fill color right here and we copy this value and we put it in the stroke instead. So let's do 0.5 and let's change this color to this. Thought I copied that. There we go. And now we can take this fill and use a lighter color. Remove the stroke. Annoying. Let's copy the color then. And put it back. No, wrong. Oh, but this was 80. And we should do the same here. So the stroke was 30. The fill 80. Alright, something like that. Maybe a little lighter though. No, not that light. This is good. And which one's that? It's the B. So let's undo this. Go back in here, paste it in. And let's do the same thing right here. Okay. That's a pretty good design, no? I think it is. I think it is. Maybe this stroke is a little bit too dark. Let's select both of those. Go into the stroke and let's do 50 instead. Alright, that's pretty good. Alright, so we have a window. Let's save this thing. Okie dokes. So the next step is to let's copy this thing. Let's open a temporary document, paste this in, and let's remove those placeholders from this thing. Like so. And let's put this somewhere around here. And we can change the size of this background thing. Wonder how we do that. Edit artboards, that must be it. So let's make it small like this. And maybe we can even save this to its own file. Let's say window 2. And I want to export this into a regular file format. So this is a little bit different depending on if you're using a Mac or a Windows. I think you need to use export on Windows. I'm not 100% sure. And maybe we can do that here as well. Export for screens. And let's do PNG. Don't need to create any subfolders or open. Let's do the full document. Maybe not. Export. And let's double check that it looks right. If we go to artboard, well, we should name this otherwise. Let's call this the let's call it win, and let's color it so we know this is the end result. If we go to get info, we can see how big it is, 432, 234, that's perfect. And it looks like this. It became a little bit weird though with the transparency. Maybe we can change that. So let's delete this for now. And let's select this middle thing here. Let's ungroup first. Maybe it's not grouped. Let's lock this thing because I want to go to this thing in the middle here, the white part. Maybe that's not its own object though, but it should be. So let's draw a box like this, and let's give it a fill of white. And let's save this in. And now if we export this, it will look a little bit better. And this should be the win. Let's make it blue, and now it still looks a little bit weird because the outer black frame does not show properly on this screen, on this right here, but it is okay, I think. Except for this to the right here. Let's fix that. It should be perfect, right? Since we are going to use it for our graphical user interface. So let's go back into window 2. Let's pick this right one here. we lock this one and we click here, maybe we need to do this. And now we give it a white fill. Okay, now I think it should be all right. Yeah, I think so. All right, one last time. We export for screens, export artboard, we save and we close. Change this to when, make it blue, and there we go. Still, it looks a little bit weird because of this frame right here and the background color, which is gray in this case. But if we were to open this in Photoshop, for instance, it looks okay. So that's nice, and it's transparent up here, which makes it a little bit easier when we want to add the texts later on, I think. Never mind, we'll figure it out. So, all right, now we have the window. The next logical step is, well, going into Photoshop and cut out the different parts of this. So for instance, we're gonna make one image with just this bottom scroll bar right here, and one image with a right scroll bar, and then one image with this whole title bar thing, including this gray thing right here, the separator. And finally, we're gonna make a very zoomed in thing, and then we will select something like this portion, which we can use to draw the frame, and we will need to do the same with this right here. So when we have all of these different parts, then we can just use them when we want to draw a window and puzzle it together. So that's enough for this section. We will continue right after this. All right, you guys, welcome back. So before the break, we managed to design our graphical user interface. So let's see where we put it. I think, yeah, this is the one. So let's open this in Photoshop, because the next step, as I mentioned before, is to cut all the pieces that we need to use. But I think before we do that, I want to take care of this transparency issue after all. So let's go into Windows 2 and let's see. I think we can select all of this and lock, and then we drag a box right behind all of this, and we put this to the back. So we go to arrange and send the back. Alright, so now we have a white background instead of that. thing. So let's export this for screens, and it's gonna be 1x. Yes. Alright, so let's change this to WinPNG, and now it looks right. So let's open this up in Photoshop, and let's zoom in a little bit, and let's figure out which of these different things that we need to cut. So first of all, we need all of this title bar portion here. So I think I'm gonna zoom in just a hair more. Alright, so let's cut this out, and we don't really need the frame. So let's do something like I have the fixed rate, so this should be normal, that's why. And I need this black thing here as well. So let's do something like this. Alright, so this is the title bar part. So let's just copy this. Let's create a new clipboard, and we'll paste this in. Alright, so that's part number one. Let's create a directory for all of these. We can call it parts. And let's save this. And let's make it we can save the Photoshop file, I guess. No, let's make it a PNG. Go into the parts, and this will be called the title bar. Alright, so that's one. What else do we need? Well, we need the scroll bars, right? So let's start with this right one, and let's decide that this right one will include this little icon. So something like this, I guess. So we copy this, we take a new clipboard, paste it in. And yeah, it looks right. So we save this one as let's call it right scroll, and we also need this bottom part, and now we will not include that little icon. So let's do this. Do the same thing. So this would be the left, the bottom scroll. Bottom scroll. Okay. So that's that. Possibly we're also going to need the frame itself. Let's look how it is constructed. It's just two lines like this. Is that the same all around? No, on the top there's only a line, no shading. what about to the right? Alright, so here we do have the shading, but it's reversed. So it's on the inner side of this thing. And here we don't have it. Alright, so since this is such a simple thing, it's just a line basically, or two lines, we don't need to take care of that. Otherwise, I would have done something like this, or rather something like, I don't know, this. And then I would have done the same down here. And then we could repeat that to make it as big as we wanted. But since it's a simple construct, we can create that ourselves instead, just by drawing pixels, basically. So, okay, I think we have what we need. So if we're able to create a square or a rectangle, then we will be able to read these files and draw the pixels based on these files and construct this nice design. That's the idea anyway. So let's get to it. Did you know that I made a book about computer networking? You will learn how the internet works and how everything works under the hood. It's a complete beginner's course, but it has some advanced elements as well. And you will learn network design and network security and all different kinds of stuff. For more info, check out books.drbirch.com. That is books.drbirch.com. Thank you for your support. Alright, welcome back you guys. So now we're going to begin the actual code. And the first thing I want to do is being able to print something on the screen. It will be helpful when we do the, when we do any error tracking. So how do we print something at this low level? Well, we need to, in the end, use assembly, but I'm going to show you how I mean by using C at the most part. So we're going to, for instance, have a void print, let's say, and this is going to take an int 8 star, so that's a string. So string. And all I'm going to do is I'm going to define a pointer. I'm going to do a for loop, and I'm going to set this to the string. And we're going to loop as long as p is not 0, and p++ at each iteration. And then I'm just going to make a call to putchar and provide this character. And then return. And in turn, the putchar is going to take an int 8, regular int 8, no star, which you call C for character. And this is going to call x putchar, which will be our assembly file. And that's how we differentiate between them as well. So this will print one character, and this will print many characters. So let's also define our signatures. So we'll have a void print int 8 star, void putchar int 8, and void let's see, we can put the, I think we'll have the assembly signature in its own file somewhere. However, we need to define all our integer types. So we're gonna have an unsigned char, which is int 8. We're gonna have an unsigned short int, which is int 16, and we have nothing bigger since this is a 16-bit code. I will also define some macros for converting. So I'm gonna have a 1 for 1 byte, which is int 8, that's 1 byte wide. I'm gonna have a 2 for a regular int 16 conversion, no star. I will also have a v for void star, and I think that's it. This is just to make it a little bit easier to cast between them. We also want a boolean, because we don't have booleans. By the way, let's take these two and put them here instead. So how do we create our own boolean? Well, first we need true and false. So let's say false is 0 and true is 1. And then we can just type def this to an unsigned char, or yeah, an unsigned char, and we'll call this boolean. Okay, what else? Well, let's create this printing function, and we need to do this in assembly. So let's see what include file we're going to use for that. Maybe we can just create one with all the signatures. So inside of the include, we create assembly.h. This will also be a pragma once. That means that this file can only be included once. And we need to include this GUI.h. So we're going to have a void x put char. It's going to take an int 8, like this. And inside of our, let's close a couple of these, starting to be too many open. So let's put the C files to the left, then the assembly files, and then the H files like this. So inside of our assembly file, we're going to define a new function, which is called xPutChar. We're going to start the same way by pushing BP and moving BP into SP. That's just how we set up our stack and how every function starts. And this time we're going to use a video interrupt in the BIOS, which is called this, write text in teletype mode. And this is a good page that lists all these types of things. I'm gonna try to remember to put this link inside of the description. Alright, so this is how we're gonna do this. We can copy this so we have it available. So let's see. Both of these can be 0. Inside of AL, that's the lower part of the register, we're going to put what we want to write. So we need to handle arguments. And then we set this to 0e. So how do we handle arguments? Well, I'm going to define a macro which I'm going to call arg, and it's going to take two things. First, an index, which argument it is, and that is going to be starting at 0. But first we need the register, and we're going to put this inside of AX and number 0. So when we have that inside of AX, we can move into the higher part of that register, 0x0e, and then we just zero out our BX register. We do the interrupt, which is int 10 in hex, so int 0x10. Afterwards we just reset the stack, so we move into SPBP, we pop BP, and we return. So all we need to do is define this argument thing. And since we're going to use that a lot, I'm going to put it inside of this include file, xgfx h. So this is going to be a macro, which is called arg, and it's going to take two arguments. And what we are going to do is we're going to move into the first argument. I'm not sure if it starts at 1 or 0 here, but I think it's 1. And what are we going to move into there? Well, we're going to move our BP plus offset. What is the offset? Well, we're going to define, maybe we can just call it off like this. So we need to calculate where in memory this thing is. And the first one is at memory position 6. And the next one is at 10. So basically we need to do 4 times and then the argument provided. So in our case this would be 4 times 0, and then we plus 6. And maybe we can, I think we can make a local, maybe it's a double, a local thing like this, because we're going to call this multiple times and we want it to work every time. So something like this, I think, and then we end the macro. I'm not 100%, we might need to modify this slightly. Okay. So we need to include our assembly. And right, I named this C. Undefined reference to X put char. Right, we need to update our make file because we create. No, we did not. So it's running blah 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 main.o xgfx.o. Didn't I export it? No. So we need to global export char. And then it compiles. So let's see if we can print something with this. So how do we use this? Well, we just do this print, and then we need to cast this with our macro, and we say something like hello world from the land of C. And a semicolon, since this, after all, is the land of C. Okay, so now we have compiled this thing. Now we just run our copy function again, or script. Let's go into the do's box and make sure it is updated. Yes, it has. So if you run GUI, hello world from the land of C, it works perfectly. So let's do one more thing before we start the actual graphics stuff. I need to be able to handle memory somehow. So I will do this pretty simply. Since we are writing directly into the hardware memory, physical memory, we need to define this stuff ourselves. So let's say we have two functions. The first is a void star, which we call alloc, and it's going to take an int16 as an argument. So this is how we allocate memory. And we're going to have a, let's say, void free all void. So very simple allocation function. We're going to allocate and just move a pointer basically. And then we just free everything at the same time. So inside of the H file, right, we're gonna have a external reference to our heap. And inside of our C file, should we put it inside of the main? Yeah, let's do that for now. So we're gonna have a global variable. Let's call it heap pointer. And this is going to point to the current top of the heap. And then we're going to create our alloc function in 16 size. Make sure that we have a size, otherwise we can return 0, cast it to void star. And if we have a size, we also need to have a pointer here, which we're going to set to the current value of the heap pointer. And by the way, we need to initialize this by setting the heap pointer equal to the heap from the beginning. So we set our P to our current heap pointer, and then we increase the heap pointer by the size, and we return P. That way we can allocate memory. And the free all is very simple. So void free all. Int no empty. We'll just reset the heap pointer back to the heap, which removes all allocations. So this is just to make things simple. I don't want to focus too much time on things around. We want to focus on the graphical user interface. And now we have all the parts needed for that to start. So let's just test that this allocation function works. So let's see if we can use it the same way as we would malloc. So let's say we allocate 8 bytes. And if we don't have a p, we can print error alloc. By the way, new lines are done this way, since we are not in a Linux environment. And then we can just return in this case. Otherwise, we want to do something with this memory so we see that it works. Let's say we do p0 is equal to something, and same with the others. So 1, 2, 3, 4, and we print A, B, C, D, and we set the last one to 0. And then we just try to print P like this. If this works, our memory allocator probably works as we would expect. So let's try it. Oh, I did not expect that actually. So let's see. If size is 0, that's the only way it can return. Did I forget to provide size? No. Maybe I need to cast this to an int16. Could that be it? How can it be 0? That's a bit weird, right? Because we do p is equal to alloc, and we send the number 8. Then we go to alloc if size is 0. Somehow it doesn't handle this argument. What if we were to do a bigger number? What happens then? Maybe even more than a character. It's weird that it works with a print function. What is the difference? Well, this is a pointer. Should we make it a pointer instead? That's a little bit weird, but why not? So let's call this SC instead. And then we do an int16 size, size is equal to, let's check that we have an SC. If we do, we set this to SC like this. Otherwise, it's a int16 0. And we need to update some more things. So this is going to take an int16 star, and when we call it, so let's see, we need to do something like int16 size, size is, and we want 8. And then we just send the address of size. Well, we can work this way, right? Here. I don't understand. How can it work when we do the print, but not work when we do this? We're basically doing the same thing, right? Check if size is true, then we provide this. Otherwise, 0. If we don't have size, we return 0. If we don't have a P, could it be that the heap pointer is 0. Let's see if we get to this point, then we know that that is the problem. We need to cast this. One, yes. Okay, so the problem is somewhere in the linking. So let's see, inside of this, we have an extern reference to the heap. Inside of our LD file, we set the heap here. Let's double check a little more carefully what exactly is going on. I think we can do -m. And let's see where we have our heap. Here's the heap pointer. Here's the heap. So it should be equal to this, no? Well, let's cheat a little bit. If we go into our assembly file, and let's define our heap. No, let's define our heap like this. And we'll say that this has, let's see, let's do this size. We define bytes and fill it with zeros. And then we define our heap, which is just a pointer to our actual heap. So I will define this as a double word. You might need to do DQ instead if you are on a 64-bit platform. And I know we are running in 16-bit code, but we still need room for it. So here we'll just do this, I guess. And here we might need this. And then we export this heap pointer. I think this is going to work. All right, so now we run this one more time. We go into here and did it update or that? 1507, yes. Maybe we cannot use this name. Let's call this heap 1 instead. And maybe we can actually remove it from our linker file. And we need to update our code. Should point to heap 1. Heap 1. And we also need to update our .h like so. Okay, now I am fairly positive it's going to work. Yes, now it works. Okay, so we needed to jump through some hoops right there, but now we're done with all the preparations. Now we can focus 100,000% on graphical user interfaces. We'll be right back after this. Alright you guys, welcome back. So now let the fun begin. We have all the necessary preparations and we can start building our shapes. So what I'm gonna do first is I'm gonna, well, close down a couple of these. And this we can keep. I'm going to create a new file for this. So let's call it shapes.c. And it's going to include our GUI.h. And do we need anything else? Yes, the assembly. So we'll also include assembly.h. And the first thing we're gonna create is a data structure for representing a pixel or a point. So let's say we have a, by the way, let's go into here and define an attribute called packed, which is just called packed like this. This is so we can easily pack structures together so they don't add any room between the variables in the memory. So we'll do struct as point, and a point has an int16x, an int16y, and it has an int8 color. But not a whole int8, we only need 16, so let's see how many bits that is. So if we have something of this type, the first one is a 1 and 2 and 4 and 8 and 16, so we need 4 bits. So let's define it like this, and we want this to be packed, and we will also do a type definition of struct as point, and this will be a point. Alright, so now we have something to work with. We are going to create more of these. Maybe we should put it in its own H file instead. Let's do that. So shapes.h, shapes.h, this will be a pragma once. We need to include GUI here as well, because we are going to use our integer types. So let's just cut this out, and we put it here. And before we begin with our functions, let's also update our make file. And the only thing we need to do is create a production rule for this. So it'll be shapes.o based on shapes.c. We will run cc with some flags, and we'll produce from an input file. And we also need to add it to our objects like this. This is the point of having a good structured make file. It makes it very easy to add stuff. Okay, so we need to have a function which initializes well, the graphics card eventually, but it'll go through the BIOS. So let's create a function which I'm going to call video mode. And let's check my documentation. No, not Outlook. So this is this first one, set video mode. And here we have a whole couple of different video modes. What we are going to start with is this resolution of 40/25 pixels, and it's going to be text. So first we're going to draw like just text-based graphics. Then we'll go over to, when that works and we can create our shapes, then we can go to this resolution right here and draw actual pixels. But we need to start somewhere, and this is where. So let's also define the resolution. So we are going to have a max X, and that is 40 pixels. We're going to have a max Y, and that is 25. I'm also going to define a constant for the actual video mode. So 40, 25. Let's do times T for text. And this is 0, as we can see here. So we'll just put a 0 there. All right. So inside of shapes, we are going to take int 8 for the video mode. And the only thing we're going to do here is we're going to call another function, which is X video mode. So that's our assembly. And we're going to put mode right there. We are, however, going to do some sanitation. So let's check that. If mode is more than the max, which is, let's see, 9F, then we are going to return. Maybe we can put it in an else because that looks a little bit better, I think. All right. By the way, this should be 0xf. Okay, so now we need a little bit of assembly. Let's open up our XGFX. And we will create a very simple function, or subroutine as it's called in assembly. So we'll have an X video mode, and we'll start as usual with the preamble, move BP into SP, and then we need to grab the video mode and make sure it's in our AL register. So we'll put it inside of AX. So we'll do arg AX first argument. And then we need to set age to 0. So XOR AH. And now we have what we need, and we issue the int 10. So int 0x10. And then we return. So we do move into SPBP, we pop BP, and we return. So a pretty simple function. As you can see, all the functions works like this, and then we do something with the argument. They all end the same. So basically this function is only this. And most of our assembly will be like that. But in order to be able to display video mode and things related to it, we also need to have some key press control so we can pause our program. So we can use this in 16, wait for key press, and we'll create a X get char. We'll start the same as usual. And here we're not going to take any arguments. We will, however, return something. So let's just zero out the whole of AX. We run the 16 interrupt. And this is what we get back. So in the assembly we can just return the AX, and returning values inside of assembly is the same as putting it into AX, so we don't need to do anything here. It's already there. So all we need to do is end our function and return. So let's export our X video mode. Let's export our X get char, and let's also create the C for this. So we have the video mode, but we also need the get char, and we should not put that inside of this file because it has nothing to do with shape. I'll put it inside of main instead. So this will be an int 8 get char. And as you can see, we get back two things. So if we press an ASCII character like a and a B or a parenthesis, then it will be put inside of AL. But if we press something like the enter key or something which is not printable, then the AL will be empty, and instead we'll get a keyboard scan code inside of AH. So we need to differentiate between these two. So let's create two registers for that. So let's say we have AL and AH, and let's also create something for the return value, and maybe also an AX for the first step. So AX will be equal to X get char, and now we need to take the upper half and put it inside of the AH and the lower half inside of AL. And we do this with binary bitwise operations. So we set AL equal to, and we take the AX and we AND it with 0x FF. Then we have the lower part. To get the higher part, we do similar thing. We take AX and we AND it with FF00 in this case. And then we also need to push this 4 bits to the left. And why do we need to do this? So let's say the AX is equal to, I don't know, 0, 1, 1, 1, 10, 10. And to get the lower part, we need to mask out this right here. And we do this by setting all of these to ones. And for ones, that is, this is wrong. This should just be F, and this should be F0. Good thing I double checked, because 3 ones is 0x F, and when we do the other one, we want to put the ones here, and then we need to fill it out with zeros, and this is 0x F0. But what we get back is just, in this second case, we will get back 0, 1, 1, 1, which we want, but we will get 4 zeros here to the right. So what we need to do is we need to push this 1, 2, 3, 4 bits so the zeros disappear. And that's what we're doing here. If you want to get more into binary bitwise operations, which I think you should, it's very useful when we deal with this low-level stuff. Then you can check out my episode, which is called Binary Operations, and I go through all of this in very much detail. Alright, so now we have an AL and an AH, and we need to check the AL if it's 0, so we can do something like this. We can set our return value. By the way, this should be an int 8. So if we, let's see, if we have an AL, then we're going to return AL, and otherwise we're going to return AH. So this will be useful when we need to deal with the keyboard later on, and also now when we just want to any key to be pressed. So let's go to our assembly and let's put our X video mode, which takes an int8 and an int8x get char void. And let's also create our signatures for our C functions. So that's video mode int8 and that's get char int8 get char void. All right. So let's see if this works. We'll clean out our main. We still need to initialize the memory though. Let's see. We can actually do a free all that will initialize the memory. And then we set the video mode, and we'll set it to our constant, which is 40 times, where was it? 25 times t. And we need to include shapes.h. Maybe we can start it with a number. Let's have an R first. That looks weird. Let's put an X here. Let's go to shapes. Shapes.h. Let's put this here, by the way. Okay, that's better. So here is where we were going to put it. So X. And then we need to jump out a little bit more. There we go. And let's also wait for a key press. So we'll just do get char like this. And that's it. Let's compile this thing. Make clean. Make. Huh. No. Okay, I must have typed wrong in the make file. Oh, it should be like this. And by the way, I remembered what flags I missed. We need to use no stdlib because there's no point in wasting a whole bunch of memory for the standard C library when we can't use it in this low-level code anyway. All right, let's try this again. Okay, compiled. So let's run the script and start DOSBox, which I closed. And we need to mount the C drive again, so we'll do this. And then run GUI. And as you can see, this changed its shape, this cursor. It's a bit wider now, and it's waiting for a key press, and then it closes. And as you can see, it's a different resolution, and maybe we want to reset that when we close. We can just type CLS and it will reset that, but I'm not really sure which is the default. Maybe it's... No, I don't know really. So let's not worry about that. All right. So now that we have this in order, now we want to be able to print one pixel. So let's just see, set cursor position. Since we're in text mode, we're gonna need to use this. So we need to set the cursor position at some point, and then we're gonna print a plus or something, and that will be our pixel at this point. All right, so let's see. We need to create a function which we'll call, maybe we can make this a boolean, since this can fail. And let's say let's call it draw point, and it's going to take a point, PNT, and probably a pointer to a point actually. And what we're going to do here is we're going to let's do this. We'll create two variables. So let's say, and this needs to be 16 by the way. So let's say this is max x and max y. Max x is equal to get max x. We're going to create that too. Max y is equal to get max y. And this is just so we have our constants, right? But this is so we have some dynamic way if we need to change that later on. Maybe we want to support different resolutions or something. So we'll have an int 8, get max, and this will just return our max x like this. We'll have one max get max y, which will return max y. Maybe, by the way, it should return max y minus 1, by the way, because it starts counting at 0. So this will make it a little bit easier to work with. So we'll have, by the way, I forgot that video mode. Did I put it? Okay, we should not put it here. It should be here, here. And then we'll have the int 8 get max x void, int 8 get max y void. and the function we're working with right now, which is boolean draw point, and it takes a point star. Okay, so now we know our max x and max y. And before that, we want to check if we don't have a point, we should return false immediately. And if our points x is more than max x, that's one condition, or our points y is more than max y, then we'll also return false. Oh. And otherwise this is okay. It can't go minus because we have we use unsigned integers everywhere. Okay, and if all this is true, let's check one more thing, by the way. Let's also check that we have initialized our video. So let's say if we're not having a video in it, we'll also return false. And we will create that as a global variable that is allowed in C after all. So boolean video init, and inside of our main we will set video init to false from the beginning, and in our video mode function we will, maybe we should do this now. We'll set our video init to true. Alright, that's all the sanitation we need. So now we will simply call an assembly for drawing this point, and let's call it xDrawPoint, and this is in text mode, so we need to differentiate that. So let's put a T at the end, and we give our points x and we give our points y. And let's also take care of the return value. So ret is going to be equal, or actually at this point we can just return the result of this. Which means we want to add the assembly as well. So now we will add that here. So we'll have an int or a boolean draw point t, and it's going to take an int 16 and then int 16, like so. And this should be called extra upon t. And now we need to create that function. So we'll have an x draw point t. We push our BP, we move BP into SP. And here we have two 16-bit inputs. So let's see what we need to do. We need to set the cursor position. And we'll use all of these registers. So I think we can put them inside of something temporary. So let's move into let's do arg ax. And we take the first argument, and we do arg bx, and we take the second. And now we need to put them into the right place. Let me just think. I think we can, let's see, row, column. So let's use the DX register here instead. So in order to put it inside of the low part, we do the same as we did in the C before. We do an AND operation on DX, and we AND it with F. And then we have the column set. Then we need to take care of the row. So we'll do an AND operation on AX with 0x, 0f like before. And we shift to the right AX by 4. So now we have it inside of AX, or the AL rather. And now we just move into DH, AL. So now we have the arguments for this call all done. So now we just do the rest. We move into, we need to zero out AX and move into AH2. And then page number. This is always going to be 0 in our case. This is basically so we, in text mode, have the ability to have several screens, and we can shift between these full-size screens. Like you do in Linux when you press the Alt key and F2, for instance. So we just need to zero out the BX. And that's it for the setting the cursor position. So we just do the int 0x10 like this. And it returns nothing, okay? Then we need to print our pixel. So let's see. Right character at current cursor. That sounds about right. So let's copy this. So we move into AH0XA. We move into AL, our character, which will be a plus sign. And I think we can zero out BX, which affects both of these B registers. And we move into CX1. And then we call int0x10. And if we get this far, we need to return true. So we move into AX0x1. And then we reset our stack by moving SP into BP, popping BP, and returning. Alright, so a lot of different things here, but I think this will make it possible to print character to the screen. Let's export this, xDrawPointT. Let's also include our shapes.h here. And let's try it out. So we need to have a constructor function for creating one of those structures. The point structure. So let's put all our constructors in one place, because there's going to be a few. Constructors. So this will create a point star, and we'll create it, call it make point, and it's going to take two int16 values. And inside of here, we can put all our constructors in the top. So we'll have a point, make point, and then we have int16x and int16y. So we'll have a point P, and P would be equal to, we also need an int16 size. Size is equal to the size of a struct S point. And P is equal to our alloc function, and we give it the size. If we don't have a P, we return a point casted 0. Otherwise, we take our P and we set the X to X, set the Y to Y, and we return P, like so. So now, we should be able to test this. We'll create a point P and T. So first we set our video mode. Then we set our point equal to a make point, and let's say we do 10, 15. if we don't have a point. I'm not sure if we actually can print an error at this point. We can try. Print memory error. Otherwise we draw point and we pass it the point. Then we get char, we free all, and we return, okay? Video init, what did I call it? Video init, video init. Right, we need to do this. Extern boolean video init. Passing argument 1 of a lock makes pointer from integer without the cat. Right, we changed that allocation function to use pointers, but that was not the error, so we can actually remove that thing. So we can remove this and this. Right, and we also need to update our H file. So this is going to take an int16 and not an int16 star. Conflicting types. Right, 37. Should be int8. Okay, it compiled. Let's run our script. And let's try this out. Would you look at that? It did print the X, but it printed it on the top line and not where I wanted it to. Okay, so the cursor position just moved. It did not take the rows into account. Let's see. The X we just ended with F. So the column worked, but the row did not work. It should be inside of DH. And we move into DH AL. This should be F0. Alright, so let's try this again. Here is update. Yes. Let's see, we take the first argument, that's the x. We end it with f. So then we have the DL value. Column. Okay, so the column works. How do we do DH? We take what we have inside of AX, which is the first argument. We end it with F0. So we get the, wait a second, we get the top half of AX, which is not what we want. We just want the bottom of that as well. And we don't need to shift anything since we are moving it into the DH. I think this is right. Okay, that's more like it. So let's see if we can draw several of these. Let's say we have point one, 0.2, and 0.3. So let's change the y to 5, and then we print 6 and 7. Huh, look at that. So now we can print all over this screen. And that's a good starting point. So when we can draw a point, we can go to the next data structure, which is going to be a line. So let's create the data structure first. So we're going to have a struct s line, And in order to draw a line, we need 2 points, one starting point and one ending point. So we'll have a point, let's see, what can we call this? Let's just call it point 1. And point 2. And here as well we do need a color. We haven't really worked with that yet, but we will. And we also need a thickness, right? What is that usually called? How thick the line is. Let's call it thickness. So we'll have an int16 thickness. We're gonna type def this into line like this. We're gonna have a constructor. So it's gonna create a line star, make line, and it's gonna take a point and a point. We haven't really taken care of the colors though, so let's add the color as well to both of these. And we also need to take care of the thickness in this case. Okay. So let's create this constructor. We're going to create a line star, make line, and it's going to take a point, point 1, and a point, point 2. Also an int8 color and an int16 thickness. Okay, so we need to do some sanitation checking. We need to see that if we don't have a point 1 or we don't have a point 2, or the thickness is 0, then we can return false like this, or like this rather. Otherwise, we set our size to the size of our line structure. if the malloc fails, we can also return 0. By the way, I want to have the cast here. So point star. And let's also add the color so we don't forget it. Int 8 color. And p color is equal to color. And now we set our different attributes. So we'll have the line P1, which will be our point 1. And our line P2 is our point P2. Line color is color, and line thickness is thickness. And then we return the line. Simple enough. Okay, so now that we can create the line structure, the next thing is we want to be able to draw that line. So we're going to have a boolean of draw line, and it's going to take a line star. So boolean, maybe we can put it next to the other one here. So boolean draw line, and we're gonna have a line ln. And we'll do the same. Let's see. Well, we need to check if we have not initialized, and if so, return false. We're also going to check if we have a point, a line or not, and if so, return false. And we don't need to sanity check anything inside of the line structure, because we can't create a line with make line if we have something wrong. So that's pretty good. However, we do need to check. Let's see. Or maybe we don't need to check. If we try to draw something outside of the screen, let us just draw it as long as it can, and then don't, instead of failing if we try to do that. I think that's a better way. So let's see, we need to have some point thing here. Okay, so basically drawing a line just means we need to repeat drawing a point a certain number of times. And even though we're not going to fail if we go outside of the screen, we still need to know the max. So let's do int 16 max x and max y. And we grab those two values. And we need to have an int16 x and a y. So let's see. We need to do some checking here. So let's see if our lines P1 X, if it's less than our lines P1 P2 X, because we need to figure out which direction we're going. So if this is less than our second point, what does that mean? So point 1, point 2, maybe we should check if it's equal. Because if those two are equal, that means we are traveling along the y-axis. So in that case, we can set our max x equal to that point's x. And we need to times this with the thickness. And we also need to have a start x and a start y. Which we'll set to well, that's going to be the x of this, because the start and the end is the same except for the thickness. Then we're going to have something similar for the y, and that's going to need to be an else if. And we will do the same calculation here. And if we don't have any equality, that means that this is not a straight line, it goes like on the diagonal, and we're not going to support that. So in that case, we fail. Okay, so that gives us the start and the end for one of the lines. Let's also create a second pair of these. So they represent the maximum possible. Wait, what did I do now? I meant to keep the old one as well. Okay, so if this max is more than the screen's max, in that case we'll set max to the screen's max. And same here, if max y is more than max y prime, we set max y to max y prime. And the start y in this case will just be the lines y and the max y is going to be the other line. And if max y is more than max y prime, we'll set max y to max y prime. Okay, so this works as long as the second point is not less than the first point. Because we're not going to be supporting drawing the line backwards. So we can actually do a check up here. If line P1 X, let's see, or let's do it like this. If line p2x is more. No. If line p1x is more than line p2x, return false. And if line p1y is more than line p2y, we'll also return false. Okay, a lot of calculations here, but this is how it needs to be done. So we'll similarly do a start x is equal to line p1x and a max x, which will be from the p2. And if max x is more than max x prime, we'll set max x to max prime. And that's all the calculations we need, I think. So now we'll just do a loop which will create this thing. So we'll do a for, and we'll set x equal to start x. We'll loop as long as x is less than max x and x plus plus. And then inside of here we'll do a for y is start y, as long as y is less than max y, y plus plus. And at each point we need to create a point. So we'll do point is equal to make point, and the x is x and the y is y. The color is the line color. And as long as we have a point, we can draw that point. And that's it. So our loop is very simple because we did all the calculations beforehand. So even though it is a lot of code and some messy code perhaps, this is probably the easiest way to do this. And as you might know, this allocates a lot of memory, but later on we're gonna create some garbage collector similar thing, so this will not be a problem. And if we get all the way down to this point, we can simply return true. All right. So let's clean this out a bit. We need a line. LN. We need a point, 2 points actually. A PNT1 and PNT2. Remove the 3. And we're not going to draw the points. However, we're going to create a line. By the way, we need the color as well. And we don't have support for that yet, so let's just set it to 0. But we still need to pass it to our respective things. And then we make a line from point 1 to point 2 with the color, and let's say the, well, we can do this, thickness. And we will define our thickness. Let's do 1 to begin with. And if we don't have a line, well, we need to do something like if we don't have a point 1, or if we don't have a point 2. We'll return. And if we don't have a line, we will do the same. And return. So at this point, we can simply draw the line ln. Okay, a lot of different calculations and code, but let's see if this works. The good thing is, if we make this work, it will be very easy to port this to the real pixels in our next video mode. All right? It's a good sign when it compiles without any error or warnings the first time. All right, let's go. That did not show much, did it? Let's see. Shape. I wonder if we are able to print some things here. Let's just try it out. Let's go up here and just do print test or something. Okay, that's good. So then we can actually add some error messages. And we don't have a printf yet. We need to fix that later on. But for now, let's do something like this. Because this will tell us quite a lot, how many times the loop runs and etc. Okay, we get the 1 and then it quits. So we get down here, but some of those start values is probably more than the max values or something. So let's see, what are we calling this function with? 10.5 to 10.15. So let's see, if our P1x, which is 10, is more than P2x, so that it's not. And if our P1y, which is 5, is more than P2y, which is 15, which is not. If P1x is equal to P2x, both are 10, so this should run. Then we set our start y to P1y to 5. We set our max y to P2y, which is 15. And if max y is more than max y prime, which we get from max y, and our constants, which is not. We'll set the start x to p1x, which is 10. We'll set the max x to p1x, that's 10, times the thickness, which is 1. So the max x is still 10. And if max x is more than max x prime, which is not. So at this point we have the start y max y, the start x max x. So we should go from 10 from 10 to 10. It's less than max x. Maybe we should have less or equal here. That's probably it. By the way, let's remove those messages. Ha! Would you look at that? Let's try it with thickness. Let's draw a fat line with 3 right here. Okay. It kind of works, but right, I think I know what's wrong. So this calculation, it times the x value, the actual value with thickness. I think we should just do a plus here actually. Yeah, we should. And now we can probably do this like we had before. Alright, that's a fat line, alright. Very nice. Let's see if we can go the other direction without modifying this code. So let's say we have a thickness of 2 and we go from 1 to 200 just to see what happens. Yeah, works. Nice. Very nice. So now the hardest work is done actually. Now we can just use this to draw a box, which is, well, it's just 4 lines, right? And when we can draw a box, that's all the shapes we're probably gonna need. And then we can go over to real graphics. So we'll be right back just after this. Alrighty guys, welcome back. So now let the fun begin. The next step is to create a rectangle. So as before, we will start by going to our shapes.h and defining the shape in question. So we're going to set a rectangle. And what is a rectangle? Well, it's actually same as a line, it's 2 points. Only both the x and the y are different from each other. So we're going to have a point P1, we're going to have a point P2, we're going to have an indate color for as before, and we're going to have no, actually not. Instead, we are going to have a foreground color, and we're gonna have a background color. We're gonna have a boolean which say if this is a, what should it be called? Well, if it has a fill or not. We can say if it's solid. And let's see. So that we have the 2 colors. We have if it's solid or not. We need to have a thickness as well on the border. And that's it, I think. And this is going to be packed, which I forgot on this one, so let's fix that. We don't want to leak memory. And then we define our type definition. Same structure as before. And we want to have a constructor which creates a rectangle. And what do we need? Well, we're going to have a point, another point, then the foreground color, background color, solid flag, and thickness. Oh, well, so the solid flag is going to be a boolean, and the thickness is an int16, like so. And maybe we should do that solid thing a little bit differently. Maybe we could have an int8 flags instead. And then we can define our flags. So let's say this is a flag solid. I don't like how this looks. Let's do flag and then we start with none. So this is 0. And then we have the flag solid. And this is this. Okay. And since I moved that, let's move it here as well. So we put the boolean at the end. Alright, so let's create our constructor. So it will be a rectangle, make rectangle. We have the point one. We have the point 2. Int8 foreground color. I think this will not fit on a single line, right? Int8 background color. And then we had the boolean, but we put it last, and in between is the thickness. So int16 thickness. And finally boolean solid. Okay. Maybe I will do like this instead. Okay, so how do we do this? First we want to check if we don't have a point 1 or 2. At this point we can have a 0 thickness because not every square necessarily needs to have a border. So this is the only thing we need to check for. And then the rest is basically pretty similar to the rest. So we want to do, let's see, we need to have a pointer for the rectangle. We need to have a size. Same as before, the size we take from the size of our structure. And then we allocate memory. And if that fails, we fail. Otherwise, we fill in all of these fields. So we take the rectangle and something is equal to something. So let's make a couple of those. So we'll have the P1, the P2, foreground color, background color, thickness, and flags. And then we just set those single values like before. And with the flags we need to do a little bit differently. We will set this equal to flag none. And then if we have a solid, in that case we will take the flags and we're gonna OR it with flag solid, like this. And then we'll just return this rectangle. Simple enough. Alright, so now we need to draw the thing. And we need a function for that. So boolean draw rectangle. And what do we need? Well, we only need a rectangle, right? Okay, so I think this function is going to be a little bit simpler than the other one. Because basically we only need to draw 4 lines. So we will have a boolean draw rectangle. We're gonna have a rectangle pointer RCT. And since we're gonna draw a couple of lines, we need to create variables for that. So we're gonna have line, and let's call them top, bottom, left, and right. We need to check if we are not initialized, and we fail. And if we don't have a rectangle, we fail. Otherwise we try to draw the thing. It might fail if we end up outside of screen or whatever, but doesn't matter if it fails. We don't need to fail the entire thing just because it doesn't fit on screen. I do, however, want to check if the top left corner is on the screen. Which means that if our rectangle P1X is more than max x, which we need to define. So int 16 max x and max y. Max x is get max x, max y is get max y. So if this is more than max x, or the RCT P1 y is more than max y, then we return false. And I also want to check if the P2 x is more or equal, no, let's see, yeah, it's more or equal to P1, so the P2 needs to be the bigger one. Or if the rectangle P2, no, I'm doing this the other way around. If P1x is more or equal to P2x, or if P1y is more or equal to P2y. Then we also want to fail. Otherwise we try to draw the thing. So we create our top by calling make line. And we provide the first point. We need to create 2 additional points actually. Since only 2 of the 4 points are provided, we can calculate the other 2, but we need to do that. So let's create what should we call this? The top right and which is the other one, the bottom left. And just to make things a little bit simpler, let's also create the other ones. So the top left and the bottom right. And we're not going to allocate for this doubly, we're just going to use them as pointers on the stack. Okay, so the top left we do have already. That is the rectangle P1. And the bottom right is the rectangle P2. And we need to create our top right by calling make point. And let's see. So the top right. Maybe we should move this down. So to calculate the top right, we make a point where the x is the top left. X. Wait a second, the x is left and right. So we need to take the x from the bottom right, actually. So the bottom right x, that is our x. The y is the top left, though. And the color is the foreground color. And to get the other one, that is the bottom left. We make another point, and the x we take from the top left x, and the y we take from bottom right y with the rectangle foreground color. I think this is right. Let's also check that if we don't have a top right or a bottom left, we can return false, because then it's a memory error. Okay, so now we have the points that we need. Now we need to turn those points into actual lines. So the top line is, we make a line from the top left to the top right. And we take the rectangle foreground color and thickness we take also from the rectangle. Then we have the bottom, which is pretty similar, only we take this from the bottom left to the bottom right. Same foreground color, same thickness. Then we take the left, we make a line from the top left to the bottom left. And finally we take the right and we make a line from the top right to the bottom right. You see, it's pretty simple to do these things when we have done the hard work of defining utility functions and taking this step by step. Otherwise, these calculations would be pretty difficult. So let's also check that we have all of these things. It's not going to segfault on my watch. Alright, so now we have 4 lines and all we need to do is to paint them. So we will draw a line with the top, we'll draw a line with the bottom and the left and the right, and there is our rectangle. We do have, however, have the things in between, the background color, but let's wait with this. I will, however, highlight it so we can find it later and remember that we need to fix that. And then we can return true at the end. All right. So let's try this out. We need a rectangle, RCT. Do video init, free all, video mode, set the color, thickness, let's have 1 for now. Don't need to make any points. Do, however, need to make a rectangle. So make rectangle, and okay, we do need 2 points actually. Let's Ctrl Z a couple of times. So we create those 2 points, and we don't need a line though. Instead we create our rectangle right here. So make rectangle, and we take our point 1, point 2, then we have the colors. Let's just use CLR for now and no background. Int 16, this is the thickness, and no fill, let's say. And then we draw the rectangle. And let's see how big this is going to be. Let's draw it from 3,3 to 10, 10. and see what happens. Unknown type RCT and draw rectangle. Implicit declaration. Make rectangle. Which was the first one? RCT. Right, this should be rectangle like this. And that's probably because why the other one failed as well, right? No, yes. P1 and P2 undeclared. 58. Right. This should be .1. Okay, it compiled. Let's see what happens. And I closed the DOS box again. Let's mount the drive. And let's run this thing. Huh! You look at that. It's not perfect though, but it's pretty close. Why is there a thickness of 2? Didn't I set it to 1? No, I didn't. So let's try that first. Okay, but it's off a little bit. Why is that? Let's check the draw line function. Maybe we should have, let's see. What if we were to do this after all? Then it would probably be one step too much, right? Now it increased the thickness, that's not what we want. What if we were to just add one to this? We also need to add one here in this case. I'm not sure if this is the right solution, but let's try. Okay, that's better. And what if we have a thickness? Does it still work? Let's say we have a thickness of 3 and we make this really big. We go from 1, 1 to something like, let me check the resolution, 40 times 25. Let's do 20. Oh, that did not work. Maybe it ends up outside of the screen, and that's why. But should it really? What if we were to go to 10, 10? What happens then? Then it kind of works. But the calculations are obviously not perfect. For this to work, we have to go 2 steps more. And since it works when we have a thickness of 1, it must have something to do with that. So when we set the max based on thickness, the length should be affected as well. So maybe instead of +1 here, we should plus the thickness. Right? I think this is right. Nice. And let's try changing the thickness. Will the calculations still hold? let's say we have two with the same size. Look at that, we can draw a rectangle, ladies and gentlemen. So the next logical step is to be able to draw actual pixels and not these text-based plus sign. Also we'll be increasing the resolution from this 40 times 25 in text mode to 640 times 480 at 16 different colors, or 16 different grayscales as it's going to be in our case. Alright, so we'll be right back right after this. Alright you guys, welcome back. So the next step is being able to draw real pixels on the screen. And if we go back to this document, what we are looking for is let's see, cursor, scroll, read, write graphics pixel at coordinate. That's the one. Alright, so we set the color value, we set the page number, column, and row. Alright, we can do that. This is pretty similar to our current assembly. This draw point T kind of thing. So let's create an X draw point without the T. Push BP and we do the rest of the initiation. And where do we want the stuff? So the column should be in CX. And the row in DX. Okay, that makes it a little bit simpler actually, because we don't need to shuffle around anything. We just put into CX our first argument, and we put into DX our second. And then we just set the rest of the values. So we XOR out AX and BX. We move into AH, 0C, and that's right, we need to take care of the color value as well. So we need to have that as a third argument. So let's do arg AX2. If we put it into AX, it will actually end up in this A low register. So we don't need to do anything other. We don't want to XOR this thing though. Okay, that's it. And then we issue the int 0x10. And we should have drawn a pixel on the screen. So then we will just move into SPBP, we pop BP and we return. Pretty simple. And let's export this thing, X draw pixel. We also need to choose a different video mode. And the one that we want is this one. So 12 should go into the AL. Let's see, we had some include for this, didn't we? Here we go. So we can define x 640 times 480 times 16 is 0x12. So maybe we should do this. And I think that's it. Yeah. We do, however, need to update our draw point. So it should call our draw point and not our draw point t. And inside of here, we need to create that x draw point in 16, and we need a color as well. So that's an int 8. So let's add this right here. Our point color. Okay, I think that's pretty much it actually. One more thing though. When we do our video in it, we want to use our other resolution and update our constants. So max x is now 640 pixels and y is 480. So let's see if we can draw the same rectangle with these settings. Unsigned conversion from int to int 8. Uh, 81. Okay, this should be an int 16 now. Undefined reference to extra point. Did I misspell it or something? Right, extra point, not pixel. Okay, it compiles. Maybe it's because we don't have a color. Perhaps color 0 is black or something. Let's set 1 here instead. One could hope, right? Okay, there is a small triangle up there. Let's use a little bit brighter color. I don't know which one it's going to be. Later we will set those colors ourselves, but for now we'll use the default. And let's make it a lot thicker, like 5. And let's go from, let's start at 10, and go to 100, 100. It crashes. That's weird. It crashes in the middle of drawing the other triangle, rectangle. Why is that? Make point. We send in 16 values. How come it crashes when it's a big rectangle but not when it's a small? Let's see which setting that fails. If we go back to 1, 1 here and go to, let's say 30, 30. And we keep the thickness of 5. Okay, that works. So how high can we get? What if we do 40, 40? Then it crashes. Maybe we run out of memory. Is that possible? That can actually be it. I did not allocate all that much for our heap. Let's see how big this is. 1,000 hex. What is that? 40k, 4k. Maybe we can add a 0 here. That should fit inside of the segment, I think. Maybe it failed to save. Okay. Maybe I went a little bit too far. What if we were to do this? So we give it 4K like before, but it's getting a couple of those. Something like this. Will that fit? Yes? Let's, to be sure, do this. Compile everything. Alright. Let's see what happens this time. Okay, that was the error. Nice. I was afraid that it was going to be really difficult to troubleshoot this. Maybe we should define something which tells the size of this thing. So let's say we have a heap size, or heap size like this, and it's going to be a, let's see, it's going to be a word, and it's going to contain the current memory address minus the start of the heap. That should be the size of the heap, right? And then we will export that thing. And inside of our memory allocator, let's say we have a new size. Where the new size is equal to the current heap pointer minus the heap. So that's the number, that's the amount of allocated bytes this far. And then we take this and we plus the size we want to add. And if this new size is more than the maximum size of the heap, then we fail. Alright, so let's see if we can draw a bigger thing then. I want to start at 1010 like before. And let's go all the way up to 500 and 300. And let's increase this thickness a little bit as well. Heap undeclared. It's called heap 1. Alright, let's see if this works. Seems like we end up outside of the screen there. That's not good. This usually means that we are that we're trying to allocate too much. So our boundary check didn't really work. The heap pointer minus the heap, that must be the current size, plus the size must be the new size. Maybe the heap size is badly defined. Maybe it should be $1. I never really remember how these things work inside of this NASM. Let's try it out. Maybe we can recompile everything. Okay, we need to restart DOSBox. We didn't get any error messages this time. Oh, that's probably because we ran out of memory and it successfully caught that. Okay, so that's good in a sense. At least our memory boundary check works. But we run out of memory awfully quick. You know what? We're gonna do a little bit of memory management. So let's see. Instead of just one heap pointer, we're going to have a second one. And let's call this heap saved. And then we're going to create two functions. So this makes it possible for us to save the current heap and reload from that position. So when we, for instance, need to do a loop, we can reload it at each iteration so we don't leak memory even temporarily. Simple but effective solution, I think. And we don't even need to use any arguments here. So if we now go to shapes.c and we go to the critical point, which probably is it's probably the draw point of the draw line here, because we make awfully many points and store them in memory. So let's say before we start doing all of that, we save the current heap, then we allocate, then we use, and when we have used, we reload the heap again. So that way we will only need 1 point of memory instead of thousands. Pretty nifty, huh? So let's see if it works. And would you look at that? That's what I call a rectangle, no? Beautiful. So now we can draw a rectangle, which means that we can draw a window. So that's, well, the lion part is done. So in the next episode, we are going to learn how to successfully parse a BMP image, and we're going to draw the pixels out of from that BMP image that we designed, so we can draw an actual window with our design. And then we just need to add mouse support and we can start using our GUI. If you like this episode, do not miss the next one. Hit the bell icon and press subscribe so you get a notification when the next episode drops. I really hope you like this episode and that you like this episode. So thank you for watching and thanks for today.